What page are you on?
I'm on 9. Sorry, I still need to
Okay, all right.
get a few things in. There's one.
So what do they want us to do for these?
Oh yeah, sorry. It's
Max,
like,
min, concavity.
yeah, any like concavity or inflection points.
Okay, not increasing, decreasing.
No, just concavity, I'm pretty sure.
Okay. So they want concavity and inflection points.
Mhm.
So we need to take the double derivative to find
Mhm.
concavity and inflection points. So the derivative, when we find this, this is product rule, right? So actually, what am I saying? This is just e to the second is just a number.
Mhm.
So that's a weird question to ask because the derivative of this is just e to the second.
Mhm.
Think of that as like, I don't know, 6 or something, right? What's the
Mhm.
derivative of 6x? Just 6.
Oh yeah.
So the double derivative is just 0.
Mhm.
So there is no concavity
Okay.
and no inflection points.
Okay, cool.
Because this, if you look at the graph of it, even, let's just take a quick look at the graph. The graph of this is just going to be a line.
Yeah.
So x times e to the second power. Again, e to the second power is just a number. So if I look at the graph of that, it's just a line.
Mhm.
It's like, again, it's like 5x, and there's no concavity in that.
Mhm.
Okay.
Yeah.
This next one, there's going to be some stuff going on. So to find the derivative of this, we have to use the product rule. So it's the first times the derivative of the second, and I'll use the chain rule for this. So 9 minus x squared to the negative 1/2, right? Times 2 negative 2x, because that's the derivative of what's inside.
Mhm.
You follow how I did that?
Yeah.
Okay, so that's just the chain rule, and the derivative of the inside here was just negative 2x. The
Mhm.
derivative of a square root is bring the 1/2 down and subtract 1. Got it? And then plus, because this is the product rule, plus the second times the derivative of the first, which is just 1.
Mhm.
So let's simplify that. To simplify this, this is the hardest part of it, perhaps. We're going to multiply this. Let's see. Well, let's first cancel some stuff out. That x and that 2 can, or that 2 and that cancel out. So let's just rewrite this. This is going to be x squared over the square root of 9 minus x squared.
Mhm.
Got it?
Yeah.
Plus, now let's rewrite this so that it has 9, the square root of 9 minus x squared in the bottom,
Mhm.
which would be that, right? Because
Yeah.
we multiplied it on the top and bottom. So that simplifies to just negative, no, not negative, to 9, because the x squareds cancel out, over the square root of 9 minus x squared.
Mhm.
Got it? So the double derivative of this is going to be, so we can rewrite this as 9 times 9 minus x squared to the negative 1/2, if we want to think of it like that. So now
Mhm.
taking the derivative is negative 9 halves, because I multiplied it down, right? Times 9 minus x squared to the negative 3 halves,
Mhm.
times the derivative of what's inside, which again is negative 2x.
Mhm.
So simplifying that, the 2 and the negatives cancel, and that just equals x and let's see, x times, I'll just keep it like this, negative 9x to negative, sorry, 9 minus x squared to the negative 3 halves.
Mhm.
Am I missing something? No, that's it, because the x I put in front. Okay, so what are we trying to do for concavity? We're setting this equal to 0.
Mhm.
So where does that equal 0? Well, it either means this equals 0, so it's either x equals 0 or 9 minus x squared to the negative 3 halves equals 0. And is that even possible?
I don't think.
Well, let's think of it like this. That's like, let's see, that's like 1 over the square root of 9 minus x squared cubed, right?
Yeah.
Is that allowed to equal 0? Is that possible for that to equal 0?
No.
No, because if I had that equal to 0, I would have a 0 in the denominator.
Right.
So that we just say, no, that can't be.
Mhm.
So the inflection point is going to be 0.
Mhm.
So the inflection point is 0. So let's put that inflection point on a number line, and let's find out what g double prime of x to the left of that is, and g
Mhm.
double prime of something to the right of that is. So let's plug in points for that. What's
Mhm.
left of 0?
-1.
Perfect. So when I plug those in, what do I get? I get, if you plug a -1 into here,
Mhm.
this is always just going to be a positive underneath here,
Mhm.
because you can't take the square root of something isn't going to be a negative number.
Mhm.
So that's just going to be a positive all the time. And then if a -1 multiplied in front of it means it'll become a negative. So this is going to be negative. So
Mhm.
that's concave down. And if you plug in a +1, that's going to be positive.
Yeah.
So that's concave up. Now, if you go back to this original problem, what we should have done at the very beginning is we should have stated that, wait a minute, there's a domain restriction. The
Mhm.
domain, x has to be between what? -3 and +3.
Yeah.
Because if you plug in like 4, let's say, that's 9 minus 16, which is a negative number, and we can't take the square root of a negative number.
Mhm.
So there's a domain restriction on this. It's between -3 and +3. So even back to here, when you're like, well, can I just plug in -3 or +3 here? You can't, because that's actually not part. Look at that. Look at this problem.
Mhm.
What's the domain restriction on this now? X can't be what? Still, it has to be between 3 and -3, but is it allowed to be equal to 3 or -3?
No.
Are you allowed to divide by 0?
No.
No. So the domain restriction on this is even more restricted. Now I don't get those endpoints.
Yeah.
So that even more clarifies that I couldn't have done that. All right, so let's just check what this looks like. The graph looks like this. Let's graph it real quick so we can see. If I multiplied x times the square root of 9 minus x squared, let's see what that looks like on our graph. What are we expecting to see? Whoops, that's not right. Delete these. What do we expect to see on our graph when we do this?
That it's um isn't it going to be what's it called? I'm blanking on it. I'm sorry.
Well, I'm not asking you what the shape will be, because I don't expect you to necessarily know that.
Mhm.
But what's definitely going to happen to the left of 0? What's going to happen?
It's going to be negative.
It's not going to be negative.
Oh,
it's
right.
going to, the shape of it is going to be what? What's CCD mean?
Concave down.
Good. And what's going to happen to the right of 0?
Concave up.
That's right. And what's happening at 0?
It's the inflection point.
Some sort of inflection. So let's see if that is what we get here when we graph it. Whoa, what's going on here? Oh yeah, look at how much I have to go in there, because it's only defined where? Between what?
Between the -3 and +3.
And what do we have? Look at that. Concave. Whoops. Did I do that wrong? Concave, it should be concave up to the left and concave down to the right. So what did we do wrong? I did something wrong here. Did I plug it in wrong? No, I didn't plug it in wrong. So what did I do wrong? This should be positive here, and this should be negative here. So I made a mistake somewhere with the sign. Was this 1/2 not supposed to be there, and that -2? Negative 1/2.
The -2 is supposed to be there, but I don't know.
The 2's canceled. Let's see. When I plugged in 1/2, well, that's always going to be a positive. This is always going to be positive, and that's going to be a negative. So maybe there should have been a negative here that I missed. Let's go back and see. I might have missed something up here. The derivative of this was x times 1/2 9 minus x squared to the -1/2, and then multiply it by -2x plus, that's right, and then 9 minus x squared times 1, that's right. So when I simplified that, that's where I made the mistake. What should this have been right here? Oh yeah, that's a big mistake. See that negative there?
Yeah.
What should that have been? That should have been a negative x squared. So this really should be minus 2x squared. That's what that should be, right?
Yeah.
9 minus 2x squared is what that should have been on the top there. So yeah. So that's going to change some stuff in our answer. Not a ton, but it's definitely going to make that. So it's 9 minus 2x squared all over square root of 9 minus x squared. So then when I do the double derivative, it's going to be I'm going to have to do here. I'm actually going to have to do the quotient rule now.
My favorite.
Yeah, we love the quotient rule. This answer actually still is, we're still going to use this, so I'm going to keep this here because I have faith that we're going to use that based on the graph. So the quotient rule is low
D high
times the derivative of the high, which is just -4x, right? Minus high times the derivative of the low, which is 1/2 9 minus x squared to the -1/2 times -2x, right? All over low squared, which just cancels that out. So this looks like a mess, but actually it cleans up pretty nice, I believe. So this equals -4x root 9 minus x squared and minus, so let's simplify this a little bit. That 2 and that 2 cancel out. Let's be really careful with this minus sign. So it's minus. On the top, we have 9 minus 2x squared times x, because I still have that x there. And on the bottom, I have the square root of 9 minus x squared. All over 9 minus x squared. Yeah, this was a lot harder than what I thought. So What we're going to do is we're going to multiply by the square root. But we're going to multiply the top and the bottom by the square root of 9 minus x squared. And that's going to cancel this out right here.
Mhm.
It's also going to cancel the square root sign out there. Can you see that?
Yeah.
So it's going to be negative 4x, and then this is going to be 9 minus x squared minus 9 minus 2x squared times x, right? Because that just can't, this just canceled here with that. Follow?
Yeah.
All over. Now for this, I'm just going to be tricky, and I'm just going to write, remember, this would be like the first power, and this is the 1/2 power over here. So that's really just the 3/2 power.
Yeah.
Got it? Which is what we actually had at the beginning of this, but I forgot all this stuff on the top that we still have. So now let's simplify this, and it becomes negative 9x plus 2x cubed. And this becomes negative 36x, right? Plus 4x cubed. So when I simplify those, I get 6x cubed minus, it's supposed to be minus, making sure, yes, 6x cubed minus 45x.
Yeah.
This does not seem right. All over 9 minus x squared to the 3/2. Okay, this seems way wrong, but actually I do think it's right, because that means this factors, I can factor an x out, and I'll be left with x squared minus 45. And then on the bottom I have 9 minus x squared 3/2. So if I'm trying to find the zeros, the inflection points for this, well, this yields what inflection point?
Wouldn't it be 0?
That's my 0. And when I try to set this equal to 0, where do I end up? 45 divided by 6, the square root of that. 45 divided by 6. And if I take the square root of that, shoot, I'm just going to be in the right, I'm going to be in my right domain. That doesn't make sense to me. I feel like I did something wrong again. Now I'm going to be in the right domain, but I thought I was going to be in the wrong domain. I thought I was going to be outside of my, so I think I did something wrong again. Because I shouldn't have got that.
Yeah, this can just be a problem equation.
I did this the other day with someone, this exact same problem.
Really?
Yeah, and obviously we know the answer, because when we look at the graph, where's the inflection points? The only inflection point is at 0, and what's the concavity? It's concave up on the left, right, and concave down on the right.
Yeah.
So I know that that's the answer. But I made some sort of algebra mistake in here, because I think what you should get, there should be some more things canceling out in here. Or I don't know what I've done here, but I think I made a simple mistake somewhere with the sign or something. Low, D, high. I don't even know that I feel like checking it. Let's just go on to the next one. You get the idea, right?
Yeah.
I think what happened when I did it the right way is this other factor here was outside of 3. It was outside of my domain. Because remember, my domain was between -3 and 3, not including it. And I think that's what was supposed to happen.
Yeah.
And so you don't have to count those ones. Okay.
Okay.
All right. Consider this function, approximate that using tangent line approximation. So I think what a tangent line approximation is you take the derivative, because remember what the derivative gives us? It gives us the slope of the tangent line, right? So what would the slope of what would the slope of that be? Sorry, I did that wrong. What would we expect the slope at that point 0.9 be? We would expect the slope to be whatever we get when we plug this in, 0.9. So plug that into there, and that's going to be the slope at 0.9, at x equals 0.9
Okay.
of that original function. And approximate f. So we want to approximate f of 0.9. What are we? Do you have another example of this, or is this a problem that you weren't there for, that you were learning?
Problem I wasn't there for. I'm sorry.
Yeah, I'm trying to think of what they want you to do. So visualizing this graph is going to be like a quintic, right? So it's going to be something going like this. And they want us to find that 0.9. They want us to approximate f of 0.9 using tangent line approximation, but I'm not sure what they mean by that.
Yeah. I don't know if they mean like
Tangent line.
seeing like taking the derivative of the derivative and then like seeing where it is, but that's just with concavity. That's not with
Right.
the approximation.
Right, exactly. And also, like, we already can see what the function is. Like, why not just plug in 0.9? We don't have to approximate. We can find it exactly.
Right. I don't know. That's odd. Sorry.
So they want you to approximate the y value of this.
Yeah.
Okay. Well, I'm just thinking algebraically. If I had the slope would be the rise over the run. So I'm thinking like secant lines and stuff, but I mean they're not giving us.
I know. That's why I was like really
points.
So I was like,
yeah, I'm so sorry. I have to see an example of that one to be able to help you with that one.
It was
one.
hard. I just kind of threw it on there.
Yeah.
The answer's already on there. I couldn't crop it out, but I was just confused
the
as
graph
to how
of a twice differentiable function. So we do know that the double derivative exists for this one. So this is f of x. The order the values of f of 2, f prime of 2, and f double prime in order from least to greatest, and explain your reasoning. So this is f of x, right? That's f of x. So f of x, we can see f of x equals 0, or f of 2 equals 0. All right. Now we know that f prime at 2, that's the slope of the tangent line. So if we drew the tangent line in there in red, what would that look like to you?
It would look like, yeah, like that.
It would be a positive, right?
Yeah.
So that we know that that's greater than 0. We know it's greater than 0. So we can already see that that's bigger than f of 2. And then what would the double derivative be? What does the double derivative have to do with?
It has to do with the concavity.
Yep. It's negative because of what? Because f of x is concave down at x equals 2. That's why. So since this is negative, which one is the biggest? If we want to order from least to greatest, which one is the least?
The least is
this answer is not correct.
Really?
Yeah. Which one is the least? If this is negative, this is 0, and this is positive, which one is the least?
Wouldn't it be f double prime of 2? Or would it be?
That's right. That's the least because that's a negative. So the answer should be f double prime of 2. Oh, what they've done. Sorry. What do you usually write when you write it? You usually write it from least
Usually
to
write it-
greatest.
So they check
They write it in the opposite order. So there it is right, but they wrote it in a weird way.
Mhm.
This is how I would have written it.
Yeah. You know, it's funny. I can bet you like dollars to donuts if I wrote that on a test, they'd mark me wrong.
You're probably right. For sure. All right, I gotta run. I gotta pick up my daughter from church.
All right, yeah, that's totally fine.
Good luck. Sorry I couldn't help you with that last one, but that's all right. We took longer than we thought anyway.
Yeah, all right. Well, thank you so much, and I'll see you soon.
All right, yeah, and actually, you can go check that video. It may have been one that I already did. I may have posted it on my check my streams from before because I think I might have already posted that.
Okay, I'll go check it.
Okay, sounds good. But
Okay.
I know I did it, so I know I've done it before.